Okay, so here is how ultrasonic cleaning works. You have a large reservoir which has a cleaning solution, and then you've got a porous basket type vessel which contains your parts which need to be cleaned. It's typically something like car injectors, fuel injectors, which have high amounts of carbon deposits, which are pretty difficult to remove. The entire basket containing your parts gets lowered into the cleaning solution and is fully submerged. And there's a ultrasonic wave emitter which transmits high frequency waves into the fluid. And what that does is it causes vibrations in the cleaning solution at such high frequencies that it can cause cavitation. And cavitation is where there are micro pockets of air bubbles, which are really, really microscopic vacuum spaces. And those vacuum spaces, when they pop and draw matter towards them, can cause very high energy vibrations to occur on the parts that are being cleaned. And this will agitate the carbon deposits and helps remove them easily. With only a matter of, say, 5 to 15 minutes, all of the carbon deposits can be removed and the parts will come out looking shiny and new, almost like brand new injectors, for example.
The first topic we want to talk about is ultrasonic and its function, application and social-economic impacts. Ultrasonic is sound waves with frequencies higher than the upper audible limit of human hearing. This limit varies from person to person and is approximately 20 kHz. Ultrasonic devices operate with frequencies from 20 kHz up to several GHz. These short waves have more penetrating power due to their shorter wavelength. They were produced by, for example, a piezoelectric oscillator. If an alternating voltage is applied to one pair of opposite faces of the crystal, alternatively mechanical contractions and expansions are produced in the crystal and the crystal starts vibrating with the previously set frequency.
Ultrasonic activity, or we can refer to as cavitation, helps the solution to do its job. Plain water would not normally be effective. The cleaning solution contains ingredients designed to make ultrasonic cleaning more effective. For example, reduction of surface tension increases cavitation levels, so the solution contains a good wetting agent or surfactant. Correct composition of the solution is very dependent upon the item cleaned. Solutions are mostly used warm at about 50 to 65 degrees Celsius. However, in medical applications, it is generally accepted that cleaning should be at temperatures below 45 degrees Celsius to prevent protein coagulation. The resonant frequency of the transducer determines the size and magnitude of the resonant bubbles. Typically, ultrasonic transducers used in the cleaning industry range in frequency from 20 to 80 kHz. The lower frequencies create larger bubbles with more energy, as can be seen by dipping a piece of heavy-duty aluminum foil in a tank. The lower frequency cleaners will tend to form larger dents, whereas higher frequency cleaners form much smaller dents.
Let's look at the advantages of using ultrasonic cleaning methods. So first of all, the advantage is that it cleans a variety of items. It cleans items from metals, lenses, jewelry, dental tools, and etc. And it removes dirt from objects such as dust, oil, grease, and even other contaminants. This makes this a very efficient way of cleaning contaminants. Why? Because it uses bubbles which is generated through vibration, and it is that ultimately will agitate the surface and remove the dust from the surface. Because of that, the concentration of the solvent doesn't have to be very strong. So in often cases, water is used as an detergent, and water is non-toxic, non-flammable, and it's environmental friendly, which brings us to our fourth point: environmental friendly. Not only that, in most cases the clean objects comes out almost brand new, so it reduces the chances of it getting thrown away. So by doing that, you reduce carbon emissions and biodegradable waste. So ultimately, this cleaning method is cost saving, so it's less costly compared to other alternatives out there. However, there are some limitations to this method, and the one that I'll be discussing right now is that you need a skilled operator to carry out this cleaning method, because for every item that you clean, there are different types of items that can be cleaned, for example, such as metals, lenses, jewelry. For each of them, you need a certain type of heat, power, frequency of the vibration, and detergent type. So all of that can only be deduced by a skilled operator. So that is one of the limitations for this cleaning method.
So I'm going to talk about the lathe machines. Here's an introduction about the lathe machine. It is a machine that rotates a workpiece about an axis of rotation to perform various operations such as turning, facing, and drilling. We have different types of lathes. It's woodworking lathes, duplicating lathes, metalworking lathes, and pattern makers lathes. So it is important that the lathe machine, has low vibration in order to produce precise measurements of the workpiece, because if the vibration is too much on the machine, it will change the axis of rotation of the machine continuously, and it will cause the measurements of our workpiece not to be accurate, which is not good, of course. Okay, now I'm going to talk about the working principles of the lathe machine, how the lathe machine works. The lathe machine actually consists of a chuck which holds the workpiece between two rigid and strong support, and then this chuck is the part of the lathe machine that is rotating, and then there is a cutting tool that is held and fed against the revolving workpiece. The cutting tool can be placed parallel at 90 degrees or at an angle to the workpiece to perform different types of operation. For example, for the turning operation, we need to put it in parallel, and for the facing operation we need to put it at 90 degrees to the workpiece. So the video below shows how it works. This machine is actually the machine that is available in our workshop inside the university. So important parameter of the lathe machine is the speed of the lathe machine, which is usually between 1200 to 3600 rpm. Why is it important? The speed is important in classification of the lathes for vibration standards, which is explained by my friend in the next parts of the presentation.
Now I will talk about the vibration standard for lathe machine. Here we have a table for vibration severity criteria or vibration standard for turning machine or lathe machine. It shows us root mean squares overall velocity level measured in 100 Hz bandwidth. On left side of the table we have velocity in millimeter per second, and on right side we have velocity in inch per second. Then we have 4 types of machine: class 1 for small sized machines, class 2 for medium sized machines, class 3 large sized machines mounted on rigid support, and last is class 4 large sized machine on flexible support. As our lathe machine is a large sized machine and mounted on rigid bodies, so we will choose class 3. For class 3, vibration is lowest from speed 0.28 mm per second to 1.8 mm per second. satisfactory from 2.8 millimeter per second to 4.5 millimeter per second, and unsatisfactory from 7.1 to 11.2 millimeter per second. And last is unacceptable from 18 to 45 millimeter per second. So we can conclude from the table that we should keep the speed of our lathe machine from 0.28 millimeter per second to 4.5 millimeter per second for low amount of vibration and good finishing.
Application of lathe machine. One of the application of lathe machine is wood turning. Basically, wood turning it is used to make wooden objects such as baseball bats and wooden bowl. So, for the two example of wood turning process in producing baseball bats, for the first example is zero vibration process. Basically, at the end of the process, we will get a very good shape of the baseball bats. And the second example, let's say the wood turning process experience minor or huge vibration process. At the end of the day, we will get the baseball bat something like this, which is a very bad shape.